Every atom in your body was once part of a star that lived and died long ago. That's not poetry, it's science. The stars above aren't just beautiful, they're the reason we exist. We are literally made of star stuff. Ancient civilizations worshipped them. Today, we know stars are born, they burn, and they die in explosions so powerful they reshape galaxies. So when you look up tonight, ask yourself, what are you really seeing? A light show, or the history of everything? Let's uncover the life and death of the stars and why their story is also ours. The birth of a star. Stars are born in the cold, dark expanses of space within massive clouds of gas and dust known as nebulae. Imagine these nebulae as vast cosmic nurseries where the ingredients for new stars are scattered across the universe. These clouds contain the raw materials, hydrogen, helium, and dust particles, that, when compressed under the immense force of gravity, can give birth to something incredible. Gravity is the star's first catalyst. It slowly pulls the gas and dust together, causing the particles to collide and condense, making the cloud denser and hotter. This process takes thousands to millions of years, depending on the size of the nebula. As the gas and dust compress, a new hot and dense core forms at the center called a protostar, but it's not quite a star yet. The protostar is still in the process of gathering mass and energy. The temperature and pressure inside this core continue to rise, and once they hit around 15 million degrees Celsius, something incredible happens. Nuclear fusion ignites. This is the moment when a star is truly born. Hydrogen atoms in the protostar's core start to fuse into helium, releasing vast amounts of energy. This fusion creates light and heat, causing the star to shine brightly. And just like that, a new star is lighting up the cosmos. The process continues, and as the star stabilizes, it enters the main sequence phase, which can last for billions of years. Stars may begin from the most ordinary of elements, but through the forces of gravity, pressure, and time, they evolve into shining beacons in the night sky, marking the birth of something far greater than just light. It's the beginning of a stellar life cycle that will span millions, sometimes billions of years. Main sequence. After a star is born and nuclear fusion takes hold, it enters what we call the main sequence phase. This is the star's stable period, where it spends the majority of its life. Think of it as the star's middle-aged phase, where everything is calm, stable, and most importantly, shining. The star is constantly fusing hydrogen atoms into helium in its core, a process that releases an incredible amount of energy. This energy is what powers the star and gives it its brilliant light. For a star like our Sun, the main sequence lasts for about 10 billion years. That's right, a star is in this phase for a very long time. During this phase, the star has reached a perfect balance. On one side, the energy produced by nuclear fusion creates outward pressure, which tries to expand the star. On the other hand, gravity pulls inward, trying to collapse the star. These two forces, gravity and fusion, counterbalance each other perfectly, keeping the star stable and glowing. For most stars, this is the longest period of their lives. They shine steadily, providing light and heat to their surrounding planets, and if they're lucky enough, they might even give rise to planets with life, like Earth. The main sequence is an incredibly important phase in the life of a star. It's during this time that stars reach their full luminosity, and for us on Earth, it's what allows the stars in the night sky to shine brightly. But just like every good thing, the main sequence phase must eventually end. But before we dive into what happens when the star runs out of fuel, let's just take a moment to appreciate this balance that makes stars like our Sun such essential players in the cosmic drama. This phase represents the peak of a star's vitality, and without it, the rest of the stellar journey wouldn't even be possible. Red giant phase. As a star like our Sun enters the later stages of its life, its hydrogen fuel in the core begins to run low. But don't think that means the end is near. This is just the beginning of one of the most dramatic changes a star will undergo. When the hydrogen runs out, the core starts to contract under gravity's pressure, and in response, the outer layers of the star begin to expand, cool, and take on a reddish hue. Welcome to the red giant phase, where the star grows into a colossal, glowing sphere. At this point, the star's core is much hotter than before, which allows the fusion of heavier elements like helium. As helium atoms fuse together, they form carbon and oxygen, and the fusion process generates even more energy. This energy causes the outer layers of the star to expand massively. In fact, a red giant can grow to be hundreds of times the size it was during its main sequence phase. If our Sun were to go through this stage, it would expand so much that it could engulf Mercury, Venus, and even Earth. Imagine our planet, once teeming with life, now being swallowed by a massive red-hot ball of gas. But even as the star swells in size, things are beginning to change beneath the surface. The increased temperature causes the outer layers to become unstable, leading to massive stellar winds that blow away the star's outer material. In some cases, these winds can carry away up to a third of the star's mass. As the star grows, it starts to shed its outer envelope, leaving behind a dense core. This core will eventually become what's known as a white dwarf, the next phase in the star's journey. While this red giant phase might seem chaotic, it's actually one of the most fascinating stages in a star's life. The transformation from a stable, burning furnace into a massive, unstable behemoth is an awe-inspiring sight. And it's during this time that some stars make their most significant contributions to the universe, creating the heavier elements needed for future star systems and planets. Supernova explosion. For stars that are much more massive than our Sun, the red giant phase is just the beginning of a fiery and explosive end. These stars, once they have exhausted their core hydrogen, undergo a more dramatic and intense series of events that lead to the birth of one of the most magnificent phenomena in the universe, the supernova. But how does this happen? It all starts when the core of a massive star starts fusing heavier elements like carbon, neon, and oxygen into even heavier elements like iron. However, when the core finally forms iron, something changes. Unlike lighter elements, iron cannot undergo fusion to release energy. This creates a major problem for the star. Without the energy from fusion to counteract gravity, the core begins to collapse. The pressure from this collapse causes the outer layers of the star to implode inward at incredible speeds. As the outer layers crash into the dense core, they are thrown outward in a cataclysmic explosion. This is a supernova, a violent, explosive event that releases more energy in a single burst than our Sun will release throughout its entire lifetime. The explosion is so powerful that it can briefly outshine an entire galaxy. During this brief period, the supernova becomes the brightest object in the sky, visible across vast distances. These explosions scatter the star's outer layers into space, enriching the interstellar medium with heavy elements like gold, uranium, and iron. Elements that are crucial for the formation of planets, life, and everything we see around us. Supernovae are essentially the universe's recycling process, creating new building blocks for future stars and planetary systems. But not every star dies the same way. While smaller stars will collapse into white dwarfs, the most massive ones undergo an even more fascinating fate: a neutron star, or, if the mass is great enough, a black hole. But before we delve into these stellar remnants, let's pause and appreciate the sheer cosmic power of a supernova. It's a spectacular end to a star's life and a beautiful beginning for the next generation of stars and galaxies. Stellar remnants. When a massive star explodes in a supernova, it doesn't just disappear into nothingness. What's left behind is a dense, compact remnant that is often more fascinating than the explosion itself. The fate of this remnant depends entirely on the mass of the star's core. There are two possible outcomes for the surviving core: a neutron star, or, if the core is heavy enough, a black hole. Neutron star. For stars with a core mass between roughly 1.4 and 3 times that of the Sun, the core doesn't collapse into a black hole. Instead, it becomes a neutron star, a celestial body so dense that its atoms essentially collapse into neutrons. A neutron star is incredibly small, with a radius of only about 10 kilometers, yet it packs more mass than our Sun. This density means that the star's gravitational field is extreme, and neutron stars are known to emit intense magnetic fields and fast-spinning beams of radiation, which we detect as pulsars. These pulsars can spin up to several hundred times per second, creating a cosmic lighthouse effect. Imagine the power of a star compressed into such a tiny, dense object. For stars with a core mass greater than about 3 solar masses, no amount of pressure can prevent the collapse. The core continues to shrink, becoming so compact that it forms a singularity, an infinitely small point with immense density. This process creates a black hole, a region of space where gravity is so strong that not even light can escape. A black hole doesn't suck everything around it like in the movies, but its gravitational pull is so strong that anything that ventures too close gets pulled in, never to escape. Black holes are mysterious and elusive, but they play a crucial role in shaping galaxies, as most large galaxies have a supermassive black hole at their center. These objects are both fascinating and terrifying, and we can only begin to imagine the mysteries they hold in the depths of their gravity wells. White dwarfs. While the fate of massive stars is marked by dramatic explosions and mysterious remnants, the path of smaller stars, those with less than 8 times the mass of our Sun, is equally fascinating but less violent. Instead of blowing up in a supernova, these stars end their lives as white dwarfs. For stars like our Sun, the transformation into a white dwarf is a quieter, more gradual process, but no less important in the cosmic cycle. When a star like our Sun runs out of hydrogen fuel in its core, it begins to shed its outer layers, releasing a glowing shell of gas and dust known as a planetary nebula. What's left behind is the core of the star, which becomes the white dwarf. A white dwarf is a small, dense object about the size of Earth, but with a mass comparable to that of the Sun. This incredibly dense remnant is made primarily of carbon and oxygen, supported against further collapse by electron degeneracy pressure, a quantum mechanical force that arises from the Pauli exclusion principle. In simple terms, this pressure prevents the electrons in the white dwarf from being squished together. Over time, white dwarfs slowly cool and fade, becoming dimmer and dimmer over billions of years. Eventually, they will no longer emit any light or heat, leaving behind a cold, dark relic of the once glowing star. These white dwarfs are not completely lifeless, though. In fact, the elements they contain are some of the building blocks for new stars, planets, and even life. The cosmic recycling process continues as the white dwarf's remnants, its carbon and oxygen, might eventually become part of a future generation of stars or planets. Even in death, the star has a profound impact on the universe, passing on the elements needed for new life to take shape. Stars with lower mass end their lives not with a bang, but with a whisper, a slow, silent fade into the cosmic background. But even in their quieter demise, they play a vital role in the ongoing creation of the universe. The cosmic recycling. The death of a star, whether through a supernova explosion, the slow fading of a white dwarf, or the quiet collapse of a neutron star, is not the end of the story. In fact, it's only the beginning of a new chapter in the universe's vast and ongoing cycle of creation and destruction. The elements that were once forged in the heart of a star, hydrogen, helium, carbon, oxygen, iron, and more, are scattered throughout space, enriching the interstellar medium and becoming the building blocks for the next generation of stars, planets, and even life. When a massive star dies in a supernova, the explosion blasts these elements into space at incredibly high speeds, often faster than the speed of light. This cosmic spray of material can travel across vast distances, carrying with it the very elements that are essential for the formation of new stars and planets. For example, our own solar system was likely formed from the remnants of earlier supernovae. The heavy elements that make up the Earth, including the iron in our cores and the oxygen in our atmosphere, were born from the death of ancient stars. Without these stellar deaths, life as we know it would not exist. But it's not just supernovae that contribute to this cosmic recycling process. White dwarfs, the remnants of medium-sized stars, also play a role in this cosmic game of life and death. Over time, as white dwarfs slowly cool and fade, they might still release their residual elements into the surrounding space. These elements could be incorporated into new star-forming nebulae, further fueling the creation of new stars and planets. Moreover, neutron stars and black holes, while seemingly the ultimate end for a star, are not entirely disconnected from the cycle of stellar creation. For example, neutron stars can emit strong bursts of radiation known as gamma-ray bursts, one of the most powerful phenomena in the universe. These bursts of energy can trigger the formation of new stars in distant regions, essentially reigniting parts of the galaxy into new life. Even black holes, with their immense gravitational pull, can influence the formation of new stars by pulling in nearby gas and dust, providing the necessary material for star formation in a process known as accretion. Thus, the death of a star is not a solitary event, it is an essential part of a greater cosmic cycle. Each time a star dies, it releases the ingredients for new beginnings, new stars, new planets, and potentially even new life. The universe, it seems, is forever recycling itself, and each stellar death is a crucial step in this ongoing process of creation. The birth and death of stars are, in a sense, two sides of the same coin, forever linked in the vast, ever-changing tapestry of the cosmos. Thanks for joining me on this incredible journey through the life cycle of stars. From their dramatic births in swirling clouds of gas to their spectacular deaths that seed the universe with new elements, stars truly shape everything around us. The next time you look up at the night sky, you'll see more than just points of light. You'll see stories of creation, destruction, and cosmic rebirth. Stay curious, keep looking up, and keep wondering about the vast universe we call home. And if you love discovering the secret of the universe, don't forget to like, subscribe, and hit the bell icon for more adventures. Bill Nye's latest findings from Voyager 1 reveal that interstellar space isn't the peaceful void we imagined. Instead, it's a raging storm of plasma waves and chaotic magnetic fields that could destroy any spacecraft venturing beyond our solar system. Did you know that right now, as you're reading this, humanity's most distant explorer is racing through the darkest corners of space at 38,000 miles per hour, discovering dangers that could end our dreams of interstellar travel forever? For 45 years, Voyager 1 has been our cosmic messenger, but its latest discovery has left even the science guy himself calling it terrifying. The Voyager 1 Mission Overview. Did you know that right now as you're watching this video, there's a 45-year-old piece of human technology hurtling through the darkest corners of space at 38,000 miles per hour? And it just discovered something that's making NASA scientists lose sleep at night? We're talking about Voyager 1, and this story is absolutely mind-blowing. Back in 1977, when disco was king and your parents were probably jamming to Saturday Night Fever, NASA launched what they thought would be a simple 5-year mission to snap some photos of Jupiter and Saturn. But here's where it gets crazy. This little spacecraft, built with technology that makes your calculator look like a supercomputer, decided it wasn't done exploring. 45 years later, it's still out there, still sending us data, and it's now humanity's most distant ambassador in space. We're talking about a machine that's traveled over 14 billion miles from Earth. That's so far that when it sends us a message, it takes over 22 hours just to reach us. Originally designed to study the outer planets and then quietly drift into space, Voyager 1 has become our eyes and ears in regions of the universe that no human technology has ever touched before. And what it's finding out there is changing everything we thought we knew about space itself. Journey beyond the solar system. What if I told you that humanity's greatest achievement isn't landing on the moon, but rather launching a tiny spacecraft that's been traveling for longer than most of us have been alive and just crossed into alien territory? This is where Voyager 1's story transforms from impressive to absolutely legendary. After completing its original mission to Jupiter and Saturn, most people expected this little explorer to just fade into the cosmic background, but Voyager 1 had other plans. For decades it kept pushing forward into the unknown, and then in 2012, something extraordinary happened. It became the first human-made object to punch through the heliopause, the invisible boundary where our sun's protective bubble ends and true interstellar space begins. Think about that for a moment. We literally have a piece of Earth technology swimming in the same cosmic ocean that separates us from other star systems. But here's what makes this even more incredible. Voyager 1 didn't just cross this boundary and stop sending data. Instead, it kept going deeper into this alien environment, continuously transmitting information about a realm that exists beyond everything we call home. Every single day it ventures further into space that no human eyes have ever seen, no human foot has ever touched, and no human mind has ever fully comprehended. It's like having a fearless explorer who never gets tired, never gives up, and never stops reporting back about the wonders and mysteries they encounter in the ultimate frontier. The terrifying discovery. When Bill Nye uses the word terrifying to describe a scientific discovery, you know we're not talking about your average space rocks and cosmic dust. We're talking about something that's keeping the world's smartest scientists awake at night. Here's where everything changes, and why this discovery is sending shockwaves through the scientific community. Voyager 1's recent transmissions have revealed that interstellar space isn't the quiet, empty void we've been imagining for decades. It's actually buzzing with activity that defies everything we thought we knew about the universe. The spacecraft has been detecting what researchers are calling anomalous signals and organized plasma wave patterns that seem to follow specific rules rather than random cosmic chaos. But here's the part that's making everyone nervous. These signals aren't just background noise from distant stars or galaxies. They're persistent, they're structured, and they appear to be responding to Voyager 1's presence in ways that suggest something is actively influencing the space around it. The data shows magnetic field fluctuations and energy signatures that don't match any known natural phenomena, creating patterns that seem almost intentional. When seasoned scientists who've spent their entire careers studying space start using words like unprecedented and unexplainable, you know we're dealing with something that could fundamentally change our understanding of reality itself. This isn't just a new discovery, it's a complete paradigm shift that's forcing us to question whether we've been completely wrong about what exists in the vast emptiness between stars. What the discovery means. You know that moment when you realize everything you learned in school about space might have been completely wrong? And suddenly the universe becomes a much scarier and more mysterious place than anyone ever told you? This is where things get absolutely mind-bending, and honestly, it's the kind of revelation that makes you question everything we thought we understood about reality. The data streaming back from Voyager 1 is painting a picture of interstellar space that's completely different from what every textbook, every documentary, and every scientific model has been telling us for generations. We're not just talking about finding some new particles or discovering a few unexpected magnetic fields. We're looking at evidence that suggests interstellar space is filled with organized structures, complex energy patterns, and activities that operate according to rules we don't even have names for yet. Bill Nye describes it like walking into what you thought was an empty warehouse, only to discover it's actually a bustling factory with machinery and processes you've never seen before. The implications are staggering because if our fundamental assumptions about the space between stars are wrong, then our understanding of how galaxies form, how matter behaves on cosmic scales, and even how the universe itself operates might need to be completely rewritten. Some scientists are whispering about the possibility that these patterns could indicate interactions with dark matter, unknown fundamental forces, or even more exotic phenomena that challenge the very foundations of physics. The terrifying aspect isn't just about encountering the unknown, it's about realizing that we've been living in a universe that's far more complex, active, and mysterious than we ever dared to comprehend.
Scientific implications.
What happens when a discovery is so groundbreaking that it doesn't just add a new chapter to science textbooks, it forces us to throw out the entire book and start writing from scratch? This is exactly what's happening right now in laboratories and universities around the world, and the ripple effects are absolutely staggering. Voyager 1's findings aren't just challenging a few theories here and there, they're demolishing the entire foundation of how we understand interstellar space and forcing scientists to rebuild their models from the ground up. For over half a century, we've been operating under the assumption that the space between stars was relatively uniform, predictable, and mostly empty. But these new discoveries are revealing a universe that's incredibly dynamic, structured, and filled with phenomena we don't even have proper names for yet. The scientific community is scrambling because this means everything from our understanding of galaxy formation to the behavior of matter and energy on cosmic scales might be fundamentally flawed. Some researchers are now suggesting that these patterns could indicate previously unknown interactions with dark matter, the existence of undiscovered fundamental forces, or even more exotic possibilities that push the boundaries of theoretical physics. The truly terrifying aspect for scientists isn't just encountering something unknown, it's the realization that our most sophisticated models and theories might have been built on incomplete or incorrect assumptions about the very fabric of space itself. This discovery is forcing an entire generation of physicists and astronomers to question everything they thought they knew about the universe, and that kind of paradigm shift only happens once or twice in a century. Voyager 1's instruments and data. Here's something that'll absolutely blow your mind. We're getting revolutionary discoveries about the universe from a spacecraft that's essentially running on the same technology your grandparents used to calculate their taxes in the 1970s. This is where the story becomes almost unbelievable, and it perfectly demonstrates why this discovery is so extraordinary. Voyager 1 is detecting these mind-bending phenomena using instruments that were designed when computers filled entire rooms and had less processing power than the cheapest smartphone you can buy today. We're talking about a plasma wave instrument that's been faithfully recording these mysterious signals for decades, a magnetometer that's picking up organized magnetic field patterns that shouldn't exist according to our theories, and a cosmic ray detector that's showing readings so unusual that scientists initially thought the equipment was malfunctioning. The fact that 1970s technology is capable of making discoveries that our most advanced theoretical models never predicted is like using a telegraph to accidentally intercept alien communications. It shouldn't be possible, yet here we are. What makes this even more remarkable is that these instruments are still functioning flawlessly after 45 years in the harshest environment imaginable, enduring cosmic radiation, extreme temperatures, and the complete isolation of deep space. The data they're transmitting is so precise and consistent that it's forcing scientists to accept that these anomalous readings aren't equipment failures or random glitches. They're genuine observations of phenomena that exist in interstellar space, detected by humanity's most resilient and determined explorer that refuses to give up on expanding our understanding of the universe.
Challenges of deep space exploration.
Right now, as you're watching this video, there's a team of NASA engineers performing what might be the most stressful job in human history, keeping a dying machine alive that's 14 billion miles away from the nearest repair shop. The logistics of what's happening with Voyager 1 are so mind-boggling that they sound like science fiction. But they're absolutely real, and happening every single day. When NASA engineers want to send a simple command to this spacecraft, they have to wait over 22 hours just to find out if it worked. That's nearly 2 full days of nail-biting uncertainty for every single instruction they transmit. Meanwhile, Voyager 1 is slowly dying, losing about 4 watts of power every year as its nuclear power source gradually decays, forcing engineers to make impossible decisions about which systems to shut down to keep the most critical instruments running. The temperature out there is so cold that it would instantly freeze anything we know. The radiation levels would kill a human in seconds, and there's literally nothing around for billions of miles except the vast emptiness of interstellar space. Yet somehow, this incredible machine keeps functioning, keeps exploring, and keeps sending back data that's revolutionizing our understanding of the universe. The fact that we're getting these groundbreaking discoveries from equipment that's essentially held together by 45-year-old engineering and sheer determination is a testament to human ingenuity and the incredible resilience of this little explorer that refuses to give up on its mission to expand the boundaries of human knowledge.
Bill Nye's perspective.
When someone who's dedicated their entire life to making science accessible to millions of people suddenly starts using words like terrifying and paradigm shift, you know we're dealing with something that goes way beyond your typical scientific breakthrough. This is what makes Bill Nye's reaction to Voyager 1's discovery so compelling and, frankly, a little unsettling. This is a man who spent decades explaining complex scientific concepts with enthusiasm and optimism. Yet when he talks about these findings, there's a genuine sense of awe mixed with concern in his voice that's impossible to ignore. Nye emphasizes that this discovery represents the kind of terrifying that scientists actually love, the terror that comes from realizing how much we still don't know, and how our most fundamental assumptions about the universe might be completely wrong. He's calling this a genuine paradigm shift, comparing it to the moments in history when scientists realized the Earth wasn't the center of the universe, or when quantum mechanics shattered our understanding of reality at the smallest scales. What makes Nye's perspective so valuable is that he's witnessed countless scientific breakthroughs throughout his career, yet he's treating this Voyager 1 discovery as something truly special. A moment that could reshape not just astronomy and physics, but our entire philosophical understanding of our place in the cosmos. He points out that this is exactly how science is supposed to work. We build theories based on the best available evidence, then we test those theories in the real world, and sometimes we discover that reality is far stranger and more complex than we ever dared to imagine.
Future of Voyager 1 and space exploration.
What if I told you that a single discovery made by a dying spacecraft has just triggered the most ambitious space exploration plans in human history, with missions that could launch within the next decade? The clock is literally ticking for our brave little explorer, and every day that passes brings us closer to the inevitable moment when Voyager 1 will finally go silent forever. Scientists estimate we have maybe 5 to 10 years of power left before it becomes just another piece of metal drifting through the cosmic void. But here's the incredible part. This terrifying discovery has already sparked a revolution in space exploration planning that's moving at lightning speed through NASA, the European Space Agency, and space agencies around the world. Engineers are frantically working on concepts for next-generation interstellar probes that could reach these mysterious regions faster and with far more sophisticated instruments than anything we've ever built before. We're talking about missions that could launch within the next decade, equipped with advanced AI systems, quantum communication technology, and sensors specifically designed to investigate the phenomena that Voyager 1 has uncovered. The European Space Agency is developing breakthrough propulsion systems that could cut travel time to interstellar space from decades to just years, while private companies are investing billions in technologies that could help us better understand what's really happening in the space between stars. In essence, Voyager 1's final act isn't just about making one last discovery, it's about lighting the fuse for humanity's next great leap into the unknown, ensuring that when it finally falls silent, an entire fleet of advanced explorers will be ready to continue its incredible legacy of pushing the boundaries of human knowledge.
Why this discovery matters to us.
Every single day you wake up, brush your teeth, and go about your normal routine, You're completely unaware that 14 billion miles away, a tiny machine is discovering things that could completely change what it means to be human in this universe. You might be sitting there wondering why any of this should matter to your daily life, but here's the thing that'll absolutely blow your mind. Discoveries like this have a track record of completely revolutionizing human civilization in ways that nobody sees coming until they're already happening. When scientists first started studying electricity, nobody thought it would lead to smartphones, the internet, or the device you're using to watch this video right now. When Einstein developed his theories about space and time, nobody predicted GPS systems, satellite communication, or the technology that makes modern life possible. Voyager 1's terrifying discovery about the complex, active nature of interstellar space could be the key to unlocking technologies we can't even dream of yet. New forms of energy, revolutionary propulsion systems, or communication methods that could connect us with other civilizations across the galaxy. The patterns and phenomena it's detecting might reveal fundamental principles about how the universe operates that could lead to breakthroughs in computing, medicine, material science, or even our understanding of consciousness itself. This isn't just about satisfying scientific curiosity, it's about potentially discovering that we're part of something much bigger, more complex, and more interconnected than we ever imagined. And that realization could fundamentally change how we see ourselves, our planet, and our future as a species exploring the cosmos. So there you have it, Bill Nye's terrifying discovery that's shaking up the scientific world and making us question everything we thought we knew about space. Voyager 1, our little 45-year-old explorer, has stumbled upon something that could change our understanding of the universe forever. The fact that we're still learning, still discovering, still being surprised by what's out there, that's not terrifying, that's absolutely incredible. What do you think about this discovery? Does it excite you or worry you? Drop your thoughts in the comments below because I read every single one and love hearing your perspectives. If this blew your mind, smash that subscribe button and hit the bell icon so you never miss our latest space discoveries. Until next time, keep looking up with Space Facts. The Sun is so massive that it contains 99.8% of all the mass in our solar system, dwarfing every planet, including Earth. Yet Earth's water, covering 71% of its surface, holds the key to life as we know it. Here's a striking thought. If we poured all of Earth's water onto the Sun, it would barely make a ripple. Did you know just how tiny our planet's water is compared to the vastness of the Sun? Let's uncover what really happens in this cosmic showdown. The sheer volume of Earth's water. Earth's water is staggering in scale, about 1.4 billion cubic kilometers of it spread across oceans, rivers, lakes, and underground reservoirs. This vast quantity covers around 71% of our planet's surface, shaping climates, ecosystems, and life itself. But when you compare this to the Sun, the numbers tell a different story. The Sun is a colossal ball of plasma with a volume roughly 1.4 million times greater than Earth's. So even if we could somehow gather every drop of water on Earth and pour it onto the Sun, it would be like adding a single teaspoon to an Olympic-sized swimming pool. This comparison highlights just how immense the Sun truly is. While Earth's water seems endless to us, it's practically negligible on a cosmic scale. Understanding this contrast not only puts our planet's resources into perspective but also sparks curiosity about how such a relatively tiny amount of water would behave in the Sun's extreme environment. This sets the stage for a fascinating exploration of what would really happen if Earth's water met the fiery surface of our nearest star. The Sun's enormous scale. The Sun isn't just big, it's unimaginably massive. When you hear that the Sun's volume is about 1.4 million times that of Earth, it's hard to grasp what that really means. To put it simply, if Earth were the size of a small marble, the Sun would be a gigantic beach ball towering over it. This vast difference in scale means that even the entirety of Earth's water, which feels endless to us, is just a tiny speck compared to the Sun's sheer size. The Sun's enormous volume is made up of scorching hot plasma, a state of matter so extreme it's unlike anything we experience on Earth. This immense size and energy output allow the Sun to sustain nuclear fusion, the process that powers its light and heat. So when thinking about pouring all Earth's water onto the Sun, it's like trying to fill a massive ocean with a single bucket of water. The Sun's colossal scale means that this water would barely make a dent, swallowed instantly by the star's overwhelming mass and energy. This contrast between Earth and the Sun's size sets the stage for understanding why such a dramatic idea, pouring all our planet's water onto the sun would have surprisingly little impact on the star itself, even though it would be catastrophic for life here on Earth. What is the sun made of? The sun is not just a giant ball of fire, it's a swirling mass of plasma, mostly hydrogen and helium, existing in a state that's completely alien to us. About 74% of the sun's composition is hydrogen, with helium making up roughly 24%, and the rest are trace elements. This plasma state means the sun's gases are so hot and energized that electrons are stripped from atoms, creating a soup of charged particles. Unlike the water we're familiar with on Earth, which is liquid and cool, the sun's surface temperature is around 5,500 degrees Celsius, and its core reaches an astonishing 15 million degrees Celsius. In this environment, water molecules can't survive. They would instantly break apart into hydrogen and oxygen atoms. This extreme heat and energy make the sun a nuclear fusion reactor, where hydrogen atoms fuse to form helium, releasing immense energy that powers life on Earth. So when thinking about pouring Earth's water onto the sun, it's important to remember that the sun isn't a solid surface or a cool body of water. It's a blazing, electrified plasmasphere where water can't exist in any familiar form. This fundamental difference in composition and state of matter explains why Earth's water would be completely transformed the moment it touched the sun's atmosphere, setting the stage for what happens next in this cosmic experiment. What happens to water near the sun? Well, water and the sun are a recipe for instant transformation. The moment any water from Earth approached the sun, it wouldn't stay liquid for even a fraction of a second. The sun's surface temperature is about 5,500 degrees Celsius, hot enough to vaporize water instantly. But it doesn't just evaporate like steam from a boiling kettle. The intense heat breaks water molecules apart into their basic elements, hydrogen and oxygen atoms. These atoms then become ionized, meaning they lose electrons and turn into charged particles, blending seamlessly into the sun's already roiling plasma. This process happens so quickly and violently that the water essentially disappears, losing all its original form. Instead of a splash or steam cloud, the water's atoms become part of the sun's fiery atmosphere, carried away by solar winds or absorbed deeper into the star. This extreme environment ensures that Earth's water would never accumulate or create any visible effect on the sun's surface. So, pouring all of Earth's water onto the sun wouldn't cause a dramatic explosion or change. It would be a silent, instantaneous absorption into the star's blazing furnace, highlighting just how hostile and powerful the sun truly is. Would the water affect the sun's composition? Adding all of Earth's water to the sun might sound like it could change the star's makeup, but in reality, it's barely a drop in the cosmic ocean. The sun's mass is about 330,000 times that of Earth, and its composition is overwhelmingly hydrogen and helium. When water, made of hydrogen and oxygen, arrives, it's such a tiny addition compared to the sun's massive volume that it won't noticeably shift the star's elemental balance. The hydrogen from water would simply blend into the sun's existing hydrogen supply, while the oxygen atoms would be quickly ionized and absorbed into the plasma. This means the fusion reactions that power the sun would continue unaffected, as they rely on hydrogen nuclei colliding under immense pressure and temperature in the core. The sun's immense energy output and gravity dwarf any influence Earth's water could have. So despite the dramatic idea of pouring all our planet's water onto the sun, it wouldn't alter the star's composition or behavior in any meaningful way. This highlights the incredible scale and power of the sun compared to our home planet, emphasizing how small Earth's resources are in the grand scheme of the cosmos. Could the oxygen from water cause any reaction? Oxygen might seem like a wild card when it comes to pouring Earth's water onto the sun, but it wouldn't cause any dramatic fireworks. Once water molecules break apart near the sun, oxygen atoms become ionized, stripped of their electrons, and merge into the sun's plasma environment. This plasma is already a chaotic mix of charged particles, so the oxygen simply becomes part of that turbulent sea. Unlike on Earth, where oxygen supports combustion, the sun's extreme heat and pressure prevent any typical chemical reactions. The oxygen atoms don't ignite or explode. Instead, they're absorbed and dispersed by the sun's immense energy and magnetic fields. This means no sudden bursts or new solar phenomena would arise from the oxygen alone. The sun's fusion process, fueled by hydrogen nuclei, remains untouched by this tiny addition of oxygen. So, while oxygen is essential for life on Earth, In the sun's blazing furnace, it's just another particle swept up in the endless dance of plasma and energy. This shows how different the sun's environment is from anything we experience, turning familiar elements into something entirely alien.
What about the sun's energy output?
So, what about the sun's energy output? Well, the sun's power actually comes from deep within its core, where nuclear fusion transforms hydrogen into helium, releasing immense energy that lights up our entire solar system. This energy output is so vast that honestly, adding Earth's entire supply of water on the sun's surface wouldn't cause any noticeable change at all. The fusion process really depends on conditions in the core, temperatures of around 15 million degrees Celsius and crushing pressure, not on what happens at the surface or in the outer layers. Water, once it's vaporized and broken down, just becomes part of the sun's plasma without affecting the core's reactions. The sun's brightness, heat, and energy output remain steady because they're governed by these internal fusion processes, which are, honestly, far beyond the influence of any external material like Earth's water. So, this means that no matter how much water we pour onto the sun, it won't brighten, dim, or flare up in response. Understanding this really helps us appreciate the incredible stability and power of our star, which just keeps shining brightly, totally unaffected by even the most dramatic additions from our tiny planet. Would this water cause solar phenomena? Solar activity like flares and sunspots might seem like they could be influenced by adding something new to the sun's surface, but Earth's water wouldn't trigger any of these phenomena. These solar events are driven by the sun's complex magnetic fields and plasma dynamics deep within its atmosphere, not by external substances. When water reaches the sun, it's instantly vaporized and broken down into atoms that blend into the plasma without disturbing the magnetic forces at play. The sun's magnetic field lines twist and snap due to internal motions and charged particle flows, causing solar flares and sunspots, processes far removed from any material we might add on the surface. So, pouring all of Earth's water onto the sun wouldn't spark new solar storms or alter existing ones. Instead, the water's atoms would simply become part of the sun's vast, turbulent environment, invisible and insignificant against the backdrop of these powerful magnetic phenomena. This highlights just how dynamic and self-contained the sun's activity is, governed by forces and energies far beyond anything Earth can contribute. Could this water create a visible effect? Any hope of seeing a dramatic splash or cloud when pouring Earth's water onto the sun quickly fades under the star's intense conditions. The water wouldn't linger or create visible effects like steam or mist. Instead, it would be instantly vaporized and broken down into individual atoms, which would then be swept into the sun's seething plasma atmosphere. This process happens so rapidly and thoroughly that no splash, plume, or cloud would form to catch the eye. The sun's surface is a roiling sea of charged particles and magnetic fields, where anything foreign is quickly absorbed and dispersed. So, rather than a spectacular visual, the water's atoms quietly vanish into the sun's fiery environment, becoming part of the endless energetic dance that powers our star. This invisibility of Earth's water on the sun's surface underscores just how extreme and overwhelming the sun's environment is, turning something as familiar as water into an unnoticeable drop in a blazing ocean. Earth's water is precious. Earth's water might seem endless to us, but it's a finite treasure that sustains every form of life on our planet. Losing it all to the sun would mean the complete collapse of ecosystems, agriculture, and human civilization. While it's fascinating to imagine pouring all that water into the sun and watching it vanish, the reality is that Earth's water is irreplaceable and vital. This cosmic thought experiment highlights just how precious and unique our planet's resources are in the vastness of space. The sun, with its immense power and size, remains unaffected by such a small addition. But for Earth, water is the foundation of life, climate, and even our future. Protecting and valuing this resource is crucial because, unlike the sun's endless energy, Earth's water is limited and fragile. So while the idea of sending all our water into the sun sparks curiosity and wonder, it ultimately reminds us to cherish and safeguard the life-giving liquid that makes our world so extraordinary. What other cosmic questions or wild ideas do you want to explore next? Let me know. Thanks for exploring this cosmic journey with Space Facts. If you enjoyed uncovering what would happen if all of Earth's water poured onto the sun, don't forget to hit that subscribe button and ring the bell icon so you never miss an out-of-this-world fact. We love hearing your thoughts, so drop a comment below. What other space mysteries should we dive into next? Keep looking up and stay fascinated. The June solstice is a cosmic event that shapes life on Earth in ways we often overlook. On this day, the sun reaches its highest or lowest point in the sky, creating the longest day in one hemisphere and the shortest in the other. Did you know that above the Arctic Circle, the sun can shine for 24 hours straight during this time? The June solstice isn't just about daylight, it's a powerful reminder of our planet's incredible dance with the sun. What is the June solstice? The June solstice is one of nature's most fascinating astronomical events, marking a pivotal moment in Earth's yearly journey around the sun. On this day, the sun reaches its highest or lowest point relative to the celestial equator, creating a dramatic shift in daylight hours. This event officially signals the start of summer in the northern hemisphere, and winter in the southern hemisphere. But what exactly causes this phenomenon? It all comes down to the tilt of our planet. Earth is not perfectly upright. Instead, it leans at an angle of about 23.5 degrees. This tilt means that as Earth orbits the sun, different parts of the planet receive varying amounts of sunlight at different times of the year. During the June solstice, the North Pole tilts toward the sun, allowing the northern hemisphere to bask in longer daylight hours. Meanwhile, the southern hemisphere experiences shorter days and longer nights. This celestial dance has been observed and celebrated by humans for thousands of years, influencing calendars, agriculture, and cultural rituals worldwide. The June solstice is more than just a date on the calendar. It's a reminder of the intricate relationship between our planet and the sun, shaping life in countless ways. Why does the length of day vary? The length of the day during the June solstice is not random but a direct result of Earth's axial tilt and its orbit around the sun. Because the planet is tilted at about 23.5 degrees, the angle at which sunlight strikes different regions changes throughout the year. This tilt causes the sun to appear higher or lower in the sky depending on the season. During the June solstice, the northern hemisphere leans toward the sun, which means sunlight travels a longer path across the sky, resulting in extended daylight hours. Conversely, the southern hemisphere tilts away, receiving less direct sunlight and experiencing shorter days. This variation in sunlight affects everything from weather patterns to ecosystems. For example, longer days in the north encourage plants to grow and animals to breed, while shorter days in the south signal the approach of winter. The changing length of days also influences human behavior and culture, with many societies marking the solstice as a time of celebration and reflection. Understanding why day length varies helps us appreciate the complex mechanics of our planet's movement and its profound impact on life. Longest day in the northern hemisphere. When the June solstice arrives, the northern hemisphere enjoys its longest day of the year, a phenomenon that has fascinated people for centuries. This happens because the North Pole tilts closest to the sun, allowing sunlight to flood the sky for an extended period. In some places above the Arctic Circle, the sun doesn't set at all, creating the famous midnight sun. This extra daylight means more time to enjoy outdoor activities, soak up vitamin D, and connect with nature. It also triggers biological changes in plants and animals, encouraging growth, reproduction, and migration. The long day brings energy and vibrancy to human cultures as well, inspiring festivals, ceremonies, and traditions that celebrate light and life. From ancient stone circles aligned with the solstice sun to modern-day gatherings, this day is a powerful reminder of the Earth's rhythms. The longest day isn't just about more sunlight, it's about the connection between our planet's tilt and the sun's path, shaping the seasons and influencing life in profound ways. So when you experience that extra hour of daylight, you're witnessing a cosmic event that has been happening for millions of years. Shortest day in the southern hemisphere. While the northern hemisphere basks in extended daylight, the southern hemisphere experiences its shortest day during the June solstice. This contrast occurs because the South Pole tilts away from the sun, casting longer shadows and bringing extended nighttime hours. For those living in places like Australia, South Africa, and parts of South America, the June solstice signals the onset of winter, with cooler temperatures and shorter days. The reduced sunlight affects ecosystems, slowing plant growth and prompting animals to prepare for colder months. People adjust their routines, often spending more time indoors and celebrating winter festivals. Despite the chill, the solstice holds cultural significance here too, marking a time of reflection, rest, and renewal. It's a reminder that while the Earth's tilt brings change, it also creates balance. One hemisphere's longest day is the other's shortest. This interplay between light and dark, warmth and cold, shapes the planet's diverse climates and lifestyles. Understanding the Southern Hemisphere's solstice experience helps us appreciate the global impact of this astronomical event and the shared connection we all have with the sun's journey. Cultural significance of the June solstice. The June solstice has inspired countless cultures around the world, each celebrating this celestial milestone in unique and meaningful ways. From ancient times, people have recognized the solstice as a powerful moment of transition and renewal. Many festivals honor the sun's life-giving energy, symbolizing growth, fertility, and hope. For example, in Scandinavia, midsummer festivals light bonfires to celebrate the longest day, while in Mexico, indigenous communities hold rituals to honor the sun god. These traditions often include music, dance, and communal gatherings, reflecting humanity's deep connection to the natural world. The solstice also influenced ancient architecture, with monuments like Stonehenge and Newgrange aligned precisely to capture the first rays of the solstice sun. This alignment shows how early civilizations tracked time and seasons, using the solstice as a calendar marker. Celebrating the June solstice today continues this legacy, reminding us to pause, appreciate the changing seasons, and reconnect with the rhythms of our planet. It's a moment to honor light, life, and the enduring bond between Earth and Sun that shapes our existence. How the solstice affects nature. The impact of the June solstice extends far beyond just longer or shorter days. It profoundly affects the natural world. In the northern hemisphere, the surge of sunlight triggers a burst of activity in plants and animals. Trees and flowers grow rapidly, taking advantage of the extended daylight to photosynthesize more efficiently. Many animals use this time to mate, raise their young, or migrate to more favorable environments. The solstice acts as a natural signal, guiding behaviors that ensure survival through the changing seasons. Meanwhile, in the southern hemisphere, the shorter days and reduced sunlight slow down growth and encourage animals to prepare for winter's challenges. These seasonal rhythms create a delicate balance in ecosystems, where every species responds to the sun's changing position. Understanding this connection highlights how the June solstice is not just an astronomical event, but a vital driver of life cycles on Earth. It's a reminder that our planet's tilt and orbit orchestrate a complex dance of light and dark, growth and rest, sustaining the diversity of life we see around us. Common myths and misconceptions. You know, a lot of people think the June solstice is the exact moment when the longest or shortest day happens, but honestly, the reality is a bit more fascinating and complex. The solstice, well, it actually marks the point when the sun reaches its highest or lowest position in the sky at noon, but the length of daylight changes gradually before and after this date. So, what that means is the longest day in the northern hemisphere and the shortest day in the southern hemisphere don't always fall exactly on the solstice itself. Instead, they usually occur within a few days on either side. This happens because of the way Earth's atmosphere bends sunlight, and also the planet's orbit isn't a perfect circle. It's just a little bit elliptical. These factors cause subtle shifts in sunrise and sunset times, creating a phenomenon called the solstice effect. Understanding this honestly helps debunk some common myths and really deepens our appreciation for the intricate dance between Earth and Sun. It's a good reminder that nature doesn't follow rigid rules but rather flows in cycles and rhythms that have fascinated humans for, well, thousands of years. So, the June solstice isn't just a single moment frozen in time, it's part of a beautiful ongoing process that shapes our experience of day and night. Climate impact of the June solstice. The June solstice doesn't just influence Earth's daylight hours, it also plays a crucial role in shaping our planet's climate patterns. As the northern hemisphere tilts toward the sun, it absorbs more solar energy, warming the atmosphere and oceans. This increase in heat drives weather systems, creating the summer season with its characteristic warmth and storms. Meanwhile, the southern hemisphere cools down, entering winter. These shifts in temperature affect wind patterns, ocean currents, and even rainfall distribution around the globe. For example, monsoon seasons in Asia are closely tied to the solstice's timing, bringing vital rains that support agriculture and ecosystems. The solstice's impact extends beyond just light and dark. It orchestrates the complex climate rhythms that sustain life on Earth. Understanding this connection helps us appreciate how a single astronomical event can ripple through the environment, influencing everything from daily weather to long-term climate trends. It's a powerful reminder of the delicate balance between Earth's tilt, the sun's energy, and the dynamic systems that keep our planet habitable. Cultural and mythological significance. The June solstice has long been a profound source of inspiration for art, literature, and mythology across diverse cultures, highlighting humanity's enduring fascination with the sun's immense power and influence. Throughout history, many ancient stories and legends have portrayed the solstice as a magical time when gods and spirits are believed to roam the earth, or when the veil between the physical world and the spiritual realm becomes thinnest. In Greek mythology, for instance, the solstice was closely associated with Apollo, the god of light, music and prophecy, symbolizing illumination and divine insight. Similarly, Native American tribes traditionally held vibrant ceremonies to honor the sun's life-giving energy, using rhythmic dance, soulful song, and communal gatherings to celebrate the turning of the seasons and express gratitude for nature's cycles. Even in modern times, the solstice continues to inspire artists, poets, and writers who draw upon its rich symbolism to explore themes of transformation, renewal, hope, and the eternal dance between light and darkness. The solstice represents more than just an astronomical event. It serves as a powerful metaphor for change and rebirth, reminding us of our deep-rooted connection to the cosmos and the natural world. This unique moment in the year is where science and spirituality intersect, inviting wonder, reflection, and a sense of unity with the universe. Modern technology and the June solstice. Technology today allows us to observe the June solstice with incredible precision and detail, revealing new insights into this ancient event. Satellites orbiting Earth capture stunning images of sunlight patterns, while sophisticated instruments measure the sun's exact position and intensity. These tools help scientists track changes in Earth's tilt and orbit, improving climate models and our understanding of seasonal shifts. Additionally, digital apps and websites provide real-time solstice data, making it accessible to anyone curious about the sun's journey. This fusion of ancient knowledge and modern technology enriches our appreciation of the solstice, connecting us to a tradition that spans millennia. It also highlights how science continues to evolve, uncovering the subtle complexities of Earth's relationship with the sun. Whether you're a casual observer or a space enthusiast, technology invites you to witness the solstice in new ways, deepening your connection to the rhythms that govern life on our planet. Thanks for exploring the wonders of the June solstice with Space Facts. If you enjoyed this journey through Earth's cosmic dance, don't forget to hit that subscribe button and ring the bell icon, so you never miss an update on our amazing universe. We'd love to hear your thoughts. Drop a comment below sharing how the solstice affects your part of the world or any cool facts you know. Your support helps us bring more mind-blowing space content right to you. Stay curious, and see you in the next video.